Assalamualaikum, my name is Nur Nabila binti Muhammad Razan with the matrix number CE210167. So today I'm going to present about activity 1. First, we have to construct the circuit in figure 1.1, which is half-wave rectifier circuit inside the multi-sim 14.2 circuit simulator. Now I'm going to show you how I'm going to construct the circuit. Now I'm going to change the value of the voltage source into 100 volt peak to peak 50 Hz. And I'm going to change the variable resistor value into 1 ohm. And I'm going to connect all the component together. Now I'm going to test the circuit first. Next, I'm going to find the VAC, Vout using a multimeter, and the Vmax using an oscilloscope. Now I'm going to run this circuit. This is the value for VAC, and this is the value for Iout, which is current out. This is the value for Vout. This is the output waveform for the Vmax, and the value of the Vmax is 98.104 volt. So that's all from me. Thank you.
Assalamualaikum dan salam sejahtera. My name is Ahmad Adam Alfisa, matrix number CE210224. Today I will do the activity number 2. So we place all the components first. So this is the VAC, this is I out, and this is V out. So for the oscilloscope, we'll have to put division by division 20 volt per division, and then we'll adjust the Y position. As you can see, the waveform per cycle, there's a spike over here, and then the V peak of this waveform is 97.336 volt. Now we will continue to step number 7, which is adding another inductor. So we'll just snap off this connection and then add the inductor. Then we will run it. So the VAC is 70.703 volt, the I out is 302.202 milliampere, and this is the V out 30.4 volt. So for the waveform, it still has a spike in the waveform, and the V peak for this waveform is 97.476 volt. Now we will continue to step 8, which is adding another freewheeling diode. Then we will rotate this diode, put it here, then we will run it. As you can see, this is the VAC 70.273 volt. This is the I out 307.7 milliampere, and this is the V out 30.774 volt. So as you can see from the waveform, there's no spike, and then the V peak is 97.372 volt. So as you can see from in conclusion, by adding another freewheeling diode, the waveform is stable, there's no spikes. That will be all for activity number 2. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akil bin Amran. My metric number is CE210236. So here I want to show you how to construct a circuit as figure in 1.3 for activity 3 bridge rectifier using multisim. Next, set the parameter to make sure it's match up with the lab sheet given. Then back to the question. Question said measure VAC from the source Vout and the output current Iout using multimeter. So we back to the circuit. Put multimeter here. This is for V source. This is for Vout. Then we run the circuit. Adjust that. Let's see. So as you can see here, V source is 70.679 and for the Iout is 624.52 milliamp, and for the voltage out at the source here is 62.445. So here back to the question again. Then we need to observe Vout and Iout invert using oscilloscope and draw the waveform over 2 cycles. So we just need to put the oscilloscope here, connect to the source, for the current out, we need to put the current clamp to measure the Iout to make sure the graph is shown on the oscilloscope. Then to get the Iout invert, just reverse the probe direction and then connect to the oscilloscope. Now you run the circuit again and click oscilloscope. As you can see, the graph is showing that, so we need to adjust the X and Y axis to make sure the graph is shown properly. Okay, stop. So from the oscilloscope here, we can get the Vmax is equal to 98.002, and this is a graph shown to produce a I invert. So I think that's all from me. Thank you.